Yeah, welcome to the next session of the second African Conference on Big Data Analytics and AI. We have Data Analytics for Solution-Oriented Results team in this session. And we will start with the keynote presentation that will be given by Dr. Ruth Lennon from Letterkenny Institute of Technology, Ireland. And she's working on cloud technologies and DevOps and trying to ensure security characteristics in the development of DevOps particularly. And she's currently serving as the chair of ACMW. Okay, please welcome Dr. Ruth Lennon for her presentation. Thanks.
How are you? Welcome. Thank you for having me for this presentation. I'm going to share my screen. Well, I will when it allows me. Would you allow me to share the screen, please? Okay, cool. Okay, now we should be, I hope, good to go. So good morning and thank you for inviting me here. As was stated already, my name is Ruth Lennon. I work for, or I own Crave Technology Consulting. I'm also a lecturer in Letterkenny IT, and I am currently the chair of the ACMW Europe, which is a network for professionals, computing professionals, because there's a very small number of women in computing. And the great talk that I just listened to from Dr. Enzo was absolutely fantastic. It highlighted yet more of the issues that we have to deal with on a regular basis. But today I'm here to talk about DevOps for security analytics. My specialism inside in computing is DevOps. In fact, I'm on the team who are currently writing the DevOps standards. That's the IEEE P2675 standard for DevOps, which is in its final stages of ratification, and it should come out very, very shortly. We had expected it to come out pre-Christmas, and that will also hopefully be ratified as an ISO standard not long after that. We're hopeful, certainly. So I want to talk about how we can apply DevOps to improve our security analytics processes. So that's where I'm coming from today. And if we take a look, we can see that as we go through each day, there are 75 million and more threats coming through. These are cyber attacks, basic cyber attacks. They're not even all very complicated. A lot of them tend to be people just saying, can you? How hard is it to do an attack? What could I do? Can I just get into this system? I wonder, could I do that? Now, there are, of course, specialist attacks and plenty of them. And in those attacks, those are very specifically written to gain information or to obtain money. There's been a huge increase in the amount of malware that's out there specifically to take over your computer. And some examples of that were where the recent health sector computers were taken over because they hadn't been updated and they hadn't been taken care of. Now, those attacks, as I say, range from malware, phishing, exploits, and of course there are the bots. So those are the automated types of attack. And that's where we're getting to. We can now automate our types of attacks so that there doesn't have to be much effort put into it. And we could just send that piece of code out there and it will live in the ether and continuously try and attack machines until it's successful. And if it attacks 1 million machines and only one is successful, it's still made a profit because it's a short piece of code. They're never very long and they're never very hard. In fact, it took me 20 minutes the first time I learned to write an attack. 20 minutes is all it took me to get past McAfee security. Now that was then, and it has certainly improved since then. But there are always new ways, and I'm sure if I had spent a lot longer on it again, I would find new ways of attacking Sophos or McAfee or whatever else it might be. So we need to do something about it. And the biggest thing we need to do is be more aware about what we're doing. And it doesn't matter which field we're in. Every one of us is part of the problem, and I'd like to make you instead part of the solution. So what do we want to do, or why do we want to do security analytics? We want to protect our property, protect from loss of reputation, monitor the traffic that's going through, because we want to see what's going on our network, who's trying to get in, what types of communications are going on. We want to review our users and see what the risk profile is. The I Love You virus that came out many years ago was a simple email with an attachment. You click on the attachment and it opened up a virus, which then emailed itself out to everybody else in your contact list. Oh, and at the same time, it took your data, took copies of all your data on your computer, and it sent that back to a repository. Now, people didn't think, I've got an email from Ruth Lennon saying, I love you. Is that like her? Would she normally send an email like that? No. Okay, maybe it's not from her then. Those kind of questions weren't asked because people didn't think about security training. Now we need to be a bit more aware of it. What kind of problems do we bring? How can we be more aware? And how can we look at what's going on so that we can solve these problems? So that's a two-pronged approach. So in the security analysis, we can apply security to produce better defense measures. And this is only one aspect of cybersecurity, but it's a very strong aspect and it's a growing aspect. So we need to ask ourselves some really basic questions before we go to do analytics. Analytics is fantastic, but all you hear now is data analytics, ML, big data. Let's get on with it. Let's do some analytics. Why? What are you looking for? If you don't know where you're going with the analytics or what it is you're trying to do with it, you're going to come up with an answer, sure, but it's not necessarily going to be the answer to the question that you really need to know. Lies, damn lies, and statistics, you can make the data say something. It's better to find out what it is you want to do, find out what's the right data to analyze, and go from there. So why do we want to carry out that analysis? What are the priorities that we're looking for specifically? What are we trying to improve? Where is the value that we are adding to the system? What are the constraints? There may be financial constraints. There may be constraints as to which data we can look at because it contains private user information as they're sending messages back and forth. Or it may be that the system is restricted, so we can't get access to the messages that are going back and forth through that system. Maybe on a high level, but a certain amount of the information, it might be encrypted, or at least I hope it will be. Where can I get all of this information that I'm going to analyze? So I want to talk to you about some of the data that we might analyze and why it's done incorrectly at the minute. Now, we can do basic analytics, and a lot of that may be automated. And the tools do provide that for us, and that's what I want to show you. But a data analyst who can think about it, who can communicate and find out what the needs are and read and interpret the data in the correct way, they're more important because they will solve the problems for you. And an alarm has gone off, even though I silenced my phone. Okay, so moving on. So we want to look at the data that's out there. And I'm going to give you a few examples of the data that I would deal with on a relatively regular basis. So the first one is we're going to look at firewalls and what kind of information they provide. Now, I didn't choose any of the very strong and fancy firewalls, which I'm going to talk about in a few minutes, but the data I'm showing you comes from a small and simple firewall. It's one that you will find in very many companies out there, and this firewall is a FortiGate firewall. Now, when you look at the graphs that are presented to you, you'll see that, oh, it's very easy for a non-technical person to have a look at this and go, hey, this is giving me great information, it's giving me great analysis because I have got a chart in front of me that I can read. Big, visible chart. Fantastic. But is that the information you needed? Is that the information you wanted? Or is that just something that is simple to present? And that, I think, is a trap that we all fall into. So if we look at the first one, right, of the two graphs that I've got here on this page, and again, as I said, this is taken directly from a live firewall on a live system. It's an isolated system in some ways, and I have redacted most of the information from it, so it's not going to give away too much to you, but it'll give you an idea. So the first one is on security posturing. So security posturing is about how secure our system is overall, and it contains a lot of information like the hardness of the security. Have we carried out the basic bare minimum tasks that we need to do on our system? What about auditing and logging? Now, everybody loves turning on logging because we know it's important to do, but how many people go back and read the logs? And unfortunately, when you give somebody a tool and say, hey, you can do data analysis, this is how you do it, off you go. So they go off and they apply the tool, they come up with this lovely chart, and they don't realize that that outlier that's over there, in fact, that's probably the most interesting piece of information out of everything you've come back with. And because you've gone with a simple graph or a simple pie chart or whatever it might be, that one dot that was off on its own, it made my graph look messy, so I just took it out anyway. Now, the people I'm speaking to today, of course, know much better than that, and they know not to do that. But if you're talking about a security person, they're looking at the graphs that are provided to them by a firewall. Surely the people at the firewall know better. Well, they do actually, but it's presented in a different way, much further down in the system, and it's presented in text format. But what you see when you open up the firewall first is a lovely graph. So that's probably where most people stop. They go, yeah, okay, I can see most of my sections. I see which look good and which look bad. I've got my green, good. I've got my red, bad. I'll fix those things. I'll worry about those major things that are being visually presented to me as being the most important things. So I'm trying to tell you that these graphs are lightweight analytics, and they're not sufficient. Now, the second graph that we've got there, we're looking at further detail on our fabric, that is what sits underneath, what our network constructs, what our hardware is made from. And again, we're getting more details, but look at how simple the graph is. And it's good, it presents basic information to us, but it doesn't go into the depth of information we need. We're not finding out anything out about how pen testing is being carried out, or even if it's being carried out. What about security awareness training? It's not covered anywhere inside in a firewall. And why would it be? It's not something that a firewall does. But that's part of our original security posture, and it's part of what makes our systems insecure. Okay, so let's look at some of these detailed breakdowns that the system does provide for us. It gives us, for example, again, let's go through our three little pie charts that we have there. We have categories of communications that are being carried out and going through our network. So we can see that we've got our network-based communications as one device communicates with another. We've got collaboration, storage, and backup as we try to make a copy of the system and store it somewhere. We've got remote access, and then we've got our email. All very straightforward. It's easy for me to look at that graph and go, I don't need to read the rest. What about the tech used to connect to our systems? It breaks it down via browsers, client-server types, connections, network protocol, and basic P2P connections. Again, that's not giving me the level of detail that I'm going to need to find out if there is an issue, really and truly an issue in this system, because some issues are not that great big attack that we often hear of. Some of them are very small attacks, and they last a very long time. And they slowly eat away at the system. They're slowly pulling data out. And it may be, well, if the system is configured very poorly and your team is not very good, it may take quite a long time for you to find that issue. And by then, how much information has it sold on, or how much information have they taken from the system? The last of the three graphs that you can see on the right-hand side is the risk. What are our major risks? And from this, you can see high risk, low risk, medium risk, information that's being presented, and then critical or high, generally high risk items. So we can see what's going on, and it's fairly lightweight, still not getting to the crux of a problem that a data analyst would really get into. Now, I'm not saying that these tools haven't been created by data analysts. They have, and by experts, and they're created in detail and a good code, mostly. But we're still not getting to what we want. Why are people trying to attack you in your business domain? You're applying a generic firewall, but your business is very specific. Do people target you more? In the top 5 places for attack, well, the government's the top one still, but education is still in there as a top place to attack. So universities, institutes of technologies, research institutes, they're all commonly attacked. Why? Because there are students there and they're going to try something out. They're going to experiment. What harm can it do? Well, actually lots. But they're still not looking at how does this differ based on my business domain. Your firewall doesn't do that for you. You can set your very specific rules about what you let in or out of the system, but it doesn't give you that level of analysis that we're hoping to get. Now, I'll show you just a couple more. The next one is to show you that, okay, if I know that somebody is trying to attack my system and maybe they've got some low-level credentials to allow them to get into the system, I can go in and see it. And again, I've got some great graphics that make it easy for the non-analyst to be able to see what's going on. So in this case, I can see that a user with an Apple Mac laptop tried to connect to the system. Actually, they were successful. And on that Apple Mac laptop, I can tell that they had emulated Windows. I can tell their IP address, the MAC address, just in case they're spoofing. I can tell a lot of information about them. So I am getting a bit more detail as I drill down and drill down. But that takes a lot of drilling down, and you have to know what it is you want to find in order to be able to do that. Now, whilst your very specific security team will be able to do that, if you're in a small to medium-sized enterprise, you may have very few security staff, if any at all, in which case they won't know where to look to find the information, and it becomes a good bit harder. So if we look now at the last one that I wanted to show you just for today is basic security information is there. And if we click in, if you look below those 3 graphs that I had been talking about previously, you'll see that there are over 7,000 different types of attack that have happened since this set of logs were last reviewed, which was only a few days previously. 7,000 different types. That's not 7,000 attacks, it's 7,000 different types of attacks that have happened since then. And if I were to analyze this further, you'd need to go through the logs in a bit more detail. But if I were to analyze this further, you'll be able to see that many of these are actually commonly known vulnerabilities. So these are ones that are already existing. But anywhere, look at my graph, look below the graphs on the right-hand side of the column, you'll be able to see that, in fact, some of those columns or some of the rows underneath that last column is blank. And that's where it tells you whether or not this is a known issue, if this is something that is a vulnerability that has been identified, classified, and marked as a potential exploit. So the ones that have blanks are not marked. So they're not previously known. And how do we possibly identify something that we don't know about? Now, again, you'll have all come across your known knowns, your unknown knowns, your known unknowns, and your unknown unknowns to give you an idea of what you can do or what you cannot do. But this is where our data analytics comes into play. This is where it really steps up to the mark. If we apply DevOps processes to automate our analytics, if we get our analysts in to set up things properly, to understand how to train our data, to train based on the data that we have, it can very well look at what we've got and identify common patterns. It will increase the success rate of our firewalls, and it will help us identify the types of people the user behavior that is allowing attacks to happen, but also the user behavior of the attacker as they try to attack the system, so we can find out where the common faults, even if we haven't got the exact pattern of the attack itself, we might be able to identify the path for entry. What are the common tasks they do in order to be able to do that? This is often done with honeypots, but even from within the system, on live production systems, we can continue to do this analysis. And this is something I'm strongly recommending. But again, we have to go back and ask ourselves the original questions of what are we collecting with regard to data? Why are we doing it? What is the priority? And on and on. Okay, so once we have that, once we know what we're doing, we know we can gather data from even the simplest of device, such as the Fortinet FortiGate 60E. There is a newer version out there, but this is kind of a popular one. I think that people won't necessarily have updated from just yet. It gives you plenty of data you can analyze. And you're going to have more than one firewall on your system. And in fact, if you buy one of these firewalls, you're probably going to have a virtual firewall as well. And it's better to have both hardware and virtual. So you're getting data from different sources, and you can aggregate that information in a very nice way in order to give you the kind of information you're going to need to identify these patterns. There are better software or hardware even out there. I mentioned that there are a new level of firewall that we could use, and that's the, for example, the FortiAI. Now we're starting to look at things like deep learning, deep neural networks. We're trying to train our devices specifically to look for types of patterns. These types of hardware, this type of firewall, it's not cheap. It may be the case that, depending on the size of your company, it might be cheaper to hire an analyst to do a certain amount of work in the beginning to do the analysis and then compare it to what you've got and understand how specifically in your domain, how do the attacks happen? How do we leave ourselves open to attack? So we can use existing hardware and software to start to do it, and we can improve on what we've got. And even with those existing ones, we can have an issue where we've got hardware that's going to need augmenting. Okay, so I'm moving on to DevOps now, and I want to talk about how DevOps works for your particular group. So I'm going to share the screen because I think it's disappeared. What is DevOps? It's basically a way of allowing communications between all the stakeholders and to bring in automation so that we can improve our processes. And then everybody can focus on the area where the problem really lies, rather than spending too much time on repetitive tasks. So if I look at what is DevOps, it's in a simplest form, it's a way of enhancing communications between dev and ops, as per the name of it, and so that we can produce software. But it's not even that, it's more than that. It's about enhanced communication between any team members, whoever those team members are. DevOps doesn't stick with dev and ops, it's also about the rest of the team, the security team, and on and on. So it does in data analysis. And it's not necessarily about a piece of software all the time. It's anything that adds value to the company. And this infinity symbol is something you will have seen as a great descriptor of what DevOps is. So let's look at it. Let's look at a analytics workflow and see how we can apply DevOps to our workflow. We're going to take this step by step, but if we want to obtain and store raw data, we could store it in an S3 bucket. I'm choosing Amazon S3 as an example. There are plenty of places you could do it. You could do your data wrangling using any variety of tools, but I'm going to give the example of Talent. You could use Talent to do that. So Talent would draw the data from the bucket and then deal with the data prep. From there, we could do our data analysis, and we can use, again, many different types of languages. We could use R, we could use Python. I'm a big fan of Python for many reasons. So I'm going to say we'll use Python, and we'll also use pandas as well to help us with that data management and dealing with it. So then we have to do our visualization. As with everything else I've said, there are lots of different tools we could use, but as I've chosen Python as an example, I'm going to stick with it, and I'm going to say we could use, at its lowest level, we could use Plotly. Something nice and simple. So everything that's there, we can use free examples of these things just to get ourselves started if we need to. And the last thing then is, once we've got all of this done, we want to present our findings, and we could give a little HTML page, but let's face it, we're all past that. We expect as customers something much better than that. So we're generally moving towards the field of having containers. And if we're going to use containers, then what we're going to do is we're going to push our solution out on a container. Now, the next thing we're going to have is we're going to have our life cycle. So let's look at how our life cycle might translate from a traditional software life cycle to something more involving data analytics. So we still have our planning and requirements, where we do our general requirements as what's our vision, what are we looking for, why are we doing the analysis. We do our data acquisition to give us that input that we're going to need to be able to carry out the tasks. We design our architecture, we do our data processing, we develop our code while we're still writing a script. We're going to do our data integration. We're going to do a code build where we perhaps train and build a model. We're going to do our tests and our validation. And then we're going to do our final presentation in whatever format that might be. And it could be something as simple as deploy, operate, and so on. So I wanted to give you another example, and although it's more complicated, I have dropped out a few steps just so that you can see it all on the slide and it doesn't look horrific. So bear with me on this one. So in this example, we can see that we've got our data scientists, and our data scientists might connect with the IDE, GitHub, Visual Studio. They're also then, sorry, that's the dev. The data scientists might use Jupyter. They'll store their information in a modeling store, which goes again into our Visual Studio and onto our containers, finally down to our mobile phone, maybe because we're requesting the data. So if we look at this then in an AWS type example, we have again our data analyst, and they might be using Spider for their IDE. They're going to push their code to a version control repository such as Git. Perhaps they're working in a distributed team with a developer or anybody else besides. So they might use GitHub then for the remote repository. The remote repository is going to get information from an S3 bucket. Maybe your data is held in the S3 bucket. Maybe you want to make a copy of what's in GitHub into an S3 bucket so that the developer can access it. Now, you could allow them access directly to the GitHub repository, but chances are you're going to have separate repositories. So the S3 bucket might be where they get their information from. Because you're training the data, you're creating the model and training the data and coming up with a solution. They're using your results, not necessarily everything that's underneath. On the other side, the developer themselves might use a different type of IDE. Maybe they're using Eclipse. Now you could too, but whatever. They might use something different, and that's perfectly fine. You don't need to use the same type of IDE. Again, they might use local repositories to keep a copy of the code and help with version control. They might use GitHub also for their remote repository because there may be a distributed team. Depending on how large your teams are, you might find that there are teams of teams. They might push their code then to a code pipeline. Now, this is where we're getting to the interesting stuff. When they push to the code pipeline, we're going to write, as a developer, we're going to write a couple of lines of scripts where it will automate the process of bringing in the information you want, bringing in the code from GitHub automatically, kicking that all off to a set of tests. The tests will be written by the various stakeholders. So it could be the developer, it could be the analyst, but those tests are written. You don't have to hit return each time on creating those tests. You want those tests to be automatically kicked off every time you do a push to your remote repository. So we've got our code build will then take, assuming everything passed, your tester has grabbed your information, he's checked, or she has checked your model and they've accepted your model. And maybe there's a different tester who's going to check and verify, having the human in the middle, as they say, to check your code, because that's a good thing. You want to automate as much as you can, but maybe not everything or not always. It depends on the type of domain or the field of expertise where you're working. So that process is still there. I'm drawing a single person, but obviously there could be lots. There are a couple of other steps that may hit in between, but let's focus on the next one. The next phase that I wanted to look at was the code build. And in the code build, what we've got is a pipeline. So we create individual steps of do this. Now, if that's successful, do this. If that's successful, do that. So we have do this, next, next, next. And it allows us to break up our work into stages. And the analyst then can focus specifically on that part that is most interesting. And the developer focuses on supporting that analyst. So if we move further on, and I have a feeling I'm running low on time, we will use containers, perhaps, as per the previous example. We'll use a load balancer and then Route 53, perhaps, to get that information back out to the individual user. Now, let's look at some commercial offerings. I've only a couple of slides to go and I will speed up. Let's look at a couple of commercial offerings that are out there for you that will help you with all of these tasks. Amazon Machine Learning, Microsoft Azure Machine Learning, and IBM Watson. And I suspect you may be familiar with them, but they are very good. Just to give you a quick comparison, Azure, the Microsoft offering, is all about drag and drop, making it nice and easy. Amazon is all about automating the task and to try and take that kind of functionality away from you so that all you have to focus on is that problem space. And Watson is more about the very specific analysis with the automated tool, but not so much about the pipeline itself. So they have different areas of expertise or areas of specialism. ML Ops is the machine learning ops. So if we try and phrase all of this up into a single term, you'll often hear the term ML Ops, but obviously it can be wider than just machine learning. If we look at the perspective, I would suggest that at the end of all of this, what do we do as data scientists? What are we doing that's different? We have a special way of looking at things in order to gain our insights. The way we view the data, the way we view the information is what makes it interesting. It's what brings that extra value to the business. And we can automate most of these tasks. We automate them using DevOps, and that's what helps us focus our time specifically on the problem area. And this is something I'm working with a company called Exascale AI. We're working on this to try and tighten up these processes. And that's where I wanted to leave it. You can do the analytics, but focus your time on what you need to do, not on those silly steps in between that have to be carried out rather than are more interesting to be carried out. And that is my last slide. I hope I didn't go over too much. I have a feeling that was a warning that I've gone over, but I couldn't see the chat. Was that a terrible bad warning? I'm sorry.
Yeah, you are on time. Exactly. Yeah. Thank you for your nice presentation.